So, welcome back to part 2. If you have not watched part 1 yet, I highly suggest you do that. These videos are in sequence, so it'll make a lot more sense if you do them in order. If you have seen part 1 already, let's dive straight into part 2. So, in part 1, one of the things we did was we had a look at what my IP address was on my laptop. I explained how a IP address is structured, and then I showed you what the lowest possible number happens to be and the highest possible number that you can create inside binary. We then had a look at a whole bunch more about my IP address, but I'm highlighting this piece for a reason. This is really important that we understand how we can convert IP addresses. We need to know how to convert numbers into binary, from binary notation into decimal, decimal into binary. And I want to emphasize something really critical right now. In order to understand IPv6, which is something we'll be doing further down the line, in order to understand IPv6, which is based on hexadecimal, the easiest way to convert from decimal to hexadecimal is via binary. So it's imperative we know how to convert from decimal to binary, binary to hex, hex back to decimal, decimal back to binary, and so forth. So it is an important thing that we understand how to do these conversions. So with that said, what I'd like to have a look at is let's take our IP address and let's draw a magic table again here. Let me just clean that up for a second. And we're doing the, magic table. There we go, 128, 64, 32, 16, 8421. So what we want to do is we need to convert the number 192, 168, 1.114 and convert that into binary. Now, it's quite simplistic in how we do the approach. And if we take a step back here just for a quick moment, I want to show you how we were taught to do stuff in school. Or at least at my school, this is certainly the way we were taught how to do it. So in my school, we were always taught that we look at things in terms of hundreds, tens, and units. Right? So if I wanted to represent the number 5, that would be 5 units. Easy enough. If I wanted to represent the number 13, that would be 110 and 3 units. That would give me the number 13. If I want to represent the number 612, that would be 612, 110, and 2 units. So this is how we were taught when it came to a decimal-based number system. So when it's decimal-based, and decimal meaning dec, which is 10, so we're looking at a decimal or equal to a 10-based number system. When we're looking at binary, we're looking at bi equals 2. So 2-based number system. And then when we get into what's called hexadecimal, the important thing here is hex represents 6, decimal being 10. The irony is it's actually 16. So it's a 10 with the 6, right? So we got the 1 and the 6, which is a 16-based number system for hexadecimal. Now, the trick is, this was all well and good when we can increment our units between 0 to 9. And we know that when we keep on incrementing the units and we keep on changing this unit portion, I can keep on going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once I need another value, I increment the 10 column by 1 and I reset the units back to 0. Then the units go from 0 all the way to 9. Once they reach maximum, which is 9, then this would increment to another 10, which would be a 2, and you'd end up with a 0 again. Right? So hopefully this makes sense. This is decimal. This is something that I think everyone should know already. However, in binary, it's a little bit different. Binary, what we're looking at is the same principle, except we can't go from 0 to 9. That's a decimal-based system. We've got the choice to go from 0 to 1. That's it. So when I want to represent a number, I can have in the units column, if you wish, a number of 0. If I go 1 higher, that becomes a 1. If I go 1 higher, the next column needs to become a 1, and I reset the first column to a 0. If I want to go any higher than that, this remains a 1. That gets incremented by 1, which gives me another 1. If I need to go up again, well, then I have to increment this one. I can't increment this one because it's already at the highest. So let's draw another column, and what do? We turn this one into a 1, reset that one into a 0, and reset that one back to a 0 again. Increment again, I end up with 1, 0, 1, 1, 1, 0, 1, 1, 1. And that, if we fill in the blanks, would also contain all our zeros in the front of that as well. Now this is how you would add up in binary, and if we wanted to work out what the decimal equivalent is, right? So if we now wanted to convert this into a decimal-based number system, remember, if we look at our table, let me bring it up for you guys real quick. Here's our table. 1, 2, 4, 8, 16, etc. It's not units, tens, and hundreds like it is in a decimal system. It's 1, 2, 4, 8. Now let's just focus on the first three. 1, 2, and 4. So based on the fact that it's a 1, 2, and a 4, if I come back to our table over here, that means that this is equal to a 1, that's equal to a 2, and this is equal to a 4. So if I add 0 plus 0 plus 0, well, that gives me a big fat 0. If I have no 4s, no 2s, but I do have a 1, then that's equal to 1. If I have no 4s, but I have a 2 and I don't have a 0, I don't have a 1, that is equal to 2. If the 2 and the 1 are turned on, that is equal to 3. If the 4 is turned on, that's 4. If the 4 is turned on and so is the 1, that's 5. If the 4 and the 2 are turned on, I think you're getting the idea, right? There's 6. And if we've got the 1, 1, 1, so that's 4 and 2 and 1, right? Because remember, it's add it up if it's turned on, add it up if it's turned on, add it up if it's turned on, that is equal to 7. Again, remember I said this in the first video, do not forget to count 0 as a number. That means that these will give you 8 possible combinations. So 3 bits, right? If we had what's called a 3-bit number, right? And because it's binary based, 3 bits, which is exactly this, would allow you to create 8 combinations, anything from 0 to 7. Right? So this is how we do this conversion and convert numbers from binary or decimal to binary and binary into decimal. Now, that said, let's bring this guy back up and remember, what was my IP address of my PC? 192.168.1.114. So if I wanted to represent the number 192, well, the question then becomes is, can I fit 128 into 192? The answer is yes, I can, giving us a remainder of 64. Now, can 64 go into 64? Well, it certainly can, giving us a remainder of nothing. Don't forget to put your placeholders in there, and that is what 192 would look like in binary. Now, there is easier ways to do this. Of course, what I'd like to do before I show you those is let's convert the rest of this number, right? Let's get all of them done. So 168, well, we've got 128 goes into 168. Absolutely it does, which gives us a remainder of 40. 64 does not go into 40, so that remains 0. 32, however, does go into 40 once, leaving a remainder of 8. 16 cannot go into 8, but 8 can go into 8, leaving us a remainder of nothing. Now that would be what 168 looks like in binary. Now 1 is pretty straightforward, and I think you can all get that one pretty quickly, which is equal to the 1, and finally the 114. Now 128 cannot go into 114, so that is equal to 0. We then have 64, that certainly can go into 114, leaving a remainder of 50. 32 can go into 50, leaving a remainder of 18, where 16 can go into 18, leaving a remainder of 2. And that is what your entire IP address looks like in binary. Now, what I said there was a trick that you can use. Well, there is. You can use calculators. For example, here is just a standard Windows calculator. I'm going to change it from standard mode into scientific. In fact, my apologies, not scientific. Programmer mode is what I want. And from programmer mode, what I can do is say, well, what does 192 look like? So 192, that is in decimal, and you'll see it's represented here in decimal. What does it look like in binary? Well, there it is. 1100, 4 more zeros. That is exactly as we represented it here. We can do the same thing, of course, here for something like 168 and check that we've actually done our math right here. And then, of course, we could use the number 1 to confirm that we've done it correctly. And finally, we can have a look at 114 to make sure that we've converted that one correctly as well. And there is how you can do this very quickly with something like a Windows calculator. The bad news is, if you were required to do any kind of conversions or binary calculations in an exam, there is usually not calculators allowed in any type of test. So it is still imperative that you know how to do this off the top of your head or with pen and paper. So if you don't have access to a calculator, at least you have got an alternative option if you know how to do it the old-fashioned way. So this is the conversion and learning how to be able to convert numbers from decimal into binary, and then of course binary back into decimal, so is quite straightforward as well. If I randomly pick a number here, so let's say 0, 1, 1, 0, 0, 1, 1, 1. Right, complete random number. Let's have a look. If we add these up, what are they equal to? Well, we don't have 128. We do have a 64. So 64 plus 32, which gives us 96, plus a 4, which gives us 100, plus 2 is 102, plus 1 is equal to 103. So a binary value of 0, 1, 1, 0, 0, 1, 1, 1 would be equal to 103 if we would put that into decimal notation. Now we could validate that and confirm it. We could do that in one of two ways. Either tell it I'm going to represent binary notation, in which case I can put in our binary number, and it'll tell me the decimal. Or alternatively do it the other way around. Now, I know we're jumping the gun a little bit here, but here's hexadecimal. 67 is what it would look like in hex. Now, please bear in mind something very carefully here. Hexadecimal, this is not the number 67. It is the number 6 and the number 7. They're two separate things altogether. And we'll get into that hex conversion. We will certainly do that in an upcoming video. So that is giving you a little bit of an idea now of how to do the conversions, and hopefully having a better understanding of how binary works and converting binary to decimal, and of course being able to do it the other way around as well, from decimal back into binary. Again, if you haven't subscribed to our channel, please do so now, if you wouldn't mind, and like the video if you have liked it and it's helped you in any way, shape, or form. We will continue with IPv4 addressing in video 3 of this micro series.